Hi, so this is Cielo and I's project for our two-sample t-test. So for context, we compared the mean heights of boys to girls. These are our charts. They were both generated using Google Sheets. The first one is for the height of girls and the height of boys. To create the histograms, these are our data values. So we got 20 for boys and 20 for girls. For our hypothesis, the true mean of heights, for the null hypothesis, we decided that the true mean height of girls and the true mean height of boys ultimately are equal, so there's no difference. As for the alternative hypothesis, we stated that the true mean height of girls and the true mean height of boys do in fact differ. So here are the conditions. For the random condition, both groups, boys and girls, were randomly selected at our respective school. As for the 10% condition, our sample size of 20 is less than 10% of all boys, and the sample size of 20 for the girls is less than 10% of all girls. For our nearly normal model condition, you can see within our histograms that they are roughly unimodal and symmetric, so we felt that this condition could be met. As for our independent condition, boys and girls are considered independent groups, and their heights have no direct effect on one another. So because all these conditions were satisfied, it is appropriate to model the sampling distribution of the difference in the means with a t-model, and we'll perform a two-sample t-test. Our alpha level is 0.05. Now Cielo will explain the remaining half of the project. Okay, so for our mechanics, I collected the mean, standard deviation, and the sample sizes of both samples before doing any of the formulas. So this would be all of the data that we would need to calculate or to solve our formula for both the t-score and the confidence interval. So starting with the t-score, I copied down the formula on the left side and then inputted the data, as you can see on the right. And after solving this equation, I got a t-score of 8.2978. So using an online software or a degree of freedom calculator, I calculated the degree of freedom was 36. Using the degree of freedom and t-score, I solved for the p-value, which is 0.001. Since it's a two-tailed test, we would multiply that with 2, but it would be an extremely small number, so leaving it at 0.0001 just for reference. So as you can see, the p-value is significantly less than 0.05. Right here is the drawing of our rejection with the t-score. So you can see here that our t-score lies in the rejection zone with 2.028 and negative 2.028 being our critical value. So if we were to draw something for the p-value, it would be the same exact thing. The p-value would lie straight in the rejection zone. So in conclusion, our p-value is less than our alpha, and we reject the null hypothesis because of this. So there is sufficient evidence to suggest that there is definitely a difference between the true mean of heights of girls and boys. So in order to support this conclusion, we did the confidence interval equation and just solved the rest going on from there. So as you can see, on the left side is the formula, and then on the right we inputted the data. After solving it, we got 11.334 and 18.666 being the 95% range. So we are 95% confident that the true difference in heights of girls and boys falls between 11.334 centimeters and 18.66 centimeters. Don't mind the 10-year-old statements here. I was using an old reference, but in the submission I deleted this. So yeah, just girls and boys, not 10-year-olds. So note that the interval does not include the value of 0, meaning it is definitely possible that there is a difference in heights between both groups. So yeah, this is basically our two-sample t-test with all of the requirements included. Thank you for listening.